Yes, sir. Yeah, quickly. All right. So yesterday we talked about long division, and for those of you who were here yesterday, you know that one was something. All right. But today we're talking about what I consider easier, which is synthetic division. Now, synthetic division, I believe, is way easier than long division. However, the one catch with synthetic division is it only works in certain cases. So you cannot do synthetic division for every polynomial division problem you're thrown at you. You can always do long division for any polynomial division problem that's thrown at you, but synthetic division, it has to meet certain criteria. All right. Luna, can you hit the light, please? So, the first thing that you have to do is set up the chart using the root and the coefficients. So, the root is what you are dividing by. So, that's typically from your divisor. So, it's given to you as a factor, you convert it to a root. And the coefficients are the numbers in front of the variables. Now, another thing to note before we even start, synthetic division, you can only use synthetic division when your divisor, or the binomial that you're dividing by, has an a value equal to 1. Meaning, this value right here, the coefficient in front of that x of what you're multiplying by is 1. All right? So there would not be a number in front of that variable. So for example, the one that we did in warm up, you would not be able to use synthetic because it has that 2 in front of the x. So we can't use synthetic for this problem. All right. We can only use it if what we're dividing by does not have a coefficient or has a coefficient of 1 in front of that x. All right. Now, the next steps are a little bit wonky, but we'll talk about it. So we bring down the first number, multiply and add, and then repeat. All right. Then the numbers below the line are the coefficients of the answer, with the last number being the remainder. Write your answer using variables and exponents. So that's a lot. You may not know a clue what I'm talking about, but that's why we go through these things. So, first things first, they already set up the chart for us in the first example, but I want to show you how they got this 4. All right. So the first thing that they did is they took the factor that we're dividing by and they got the root from it. So remember back when we did 3.1, we were going from factors to roots, all right, or the factor to the x-intercept. How would you typically find that root? You would do what? Put it equal to 0, solve for x. So in this case, x would be equal to 4, all right? And that's what they put here. Now, the coefficients of all of our terms here, so all the numbers in front of our variables in the dividend, or what we're dividing into, they listed here. Now, when I do synthetic division, I like to draw a line before the last number. And the reason I do that is because when we finish, your remainder will be right here. So I draw that line just to remind me that that remainder will be right there. So whatever number you get after your last number, that's where your remainder will be. So I always like to draw that line. Now, here's the process, and it's actually very, very easy. So, first things first, you bring the first number listed from left to right below this line. So, we're just going to rewrite it as 2. We then take this 2 and multiply our root to it, which is 4. So, we're going to multiply this by 4 and write that value there, which is 2 times 4 is 8. We then add the 2 numbers vertical from each other, so -7 plus 8, which is +1, and we write it there. And then we repeat the process until it's all filled in. So, multiply by 4 again. This is 4. Add it. -1 plus 4 is 3. Repeat it again. Multiply by the root, which is 4. This would be 12. Add it. -12 plus 12 is 0. And we're done. Now, this is not our answer. All right? The next part of our answer, we have to put variables to these numbers. So what these numbers are is that these numbers right here, actually, no, the zero is not included. These numbers right here in front of that line that I drew, these are the coefficients of our quotient. So in other words, they're the numbers in front of the variable. But now we have to put the variable to the numbers. All right? And the way we figure out what variable we list first is we go based off of the highest exponent that we started with, which in this case is 3. And we subtract 1 from it. So 3 minus 1 is 2. That means that the first value we're going to start with is x squared. So our first term would be 2x squared. So we're taking the coefficient of 2, writing it with the x squared. Plus, and then we just go down the line in terms of degrees. So after x squared, what will be next going down in terms of degrees? What variable? 1x. So in other words, we get 1x, or you can just put x, plus what goes with a 3? What's the next one in the list going down? So we have x squared, x. What would you typically come next? Does it have a variable? No, it's just a constant 3. And since we don't have a remainder, we don't have to worry about it. So your answer, if you want to take away the 1, is 2x squared plus x plus 3. And we're done. So do you guys see how it's a lot easier than long division? Again, this, in my opinion, is a lot easier than long division because it's just a pattern. The hardest part of synthetic is 1, making sure that your root that you're multiplying by is correct, and 2, making sure you put the correct first variable and then go down. All right. Now, any questions on that one? So let's try another one. So this time they gave us kind of the graph, but they did not set it up for us yet. So we need to set it up. So first things first, we need to find the root that goes here. So again, you set x plus 3, or whatever you're dividing by, equal to 0 and solve for x. So what's x equal to? X would be equal to what? 3. Not 3. -3. If you solve for x, you'd subtract the 3 over. X is equal to -3. So that's what we're going to put right here. Now, we use the coefficients across the top. And again, you write them in order, including their signs. So going across the top, what am I writing? Right. So that's what goes across the top, just my coefficients. And make sure you include their signs. If they're negative, make sure they're negative. Guys, heads up. And then I'm going to draw my line in front of my last number just so I know where my remainder would be, if there is one. And then I'm going to start my process. So drop the first number below the line. Then what do I do? Multiply it by -3. What's 1 times -3? -3. Then I add them. What's -2 plus -3? -5. And then we repeat. So what's -5 times -3? +15. And we add them. What's -6 plus 15? +9. Multiplied by -3. What's 9 times -3? 27, or -27. And then what's -9 times -27? -36. So this time we actually do have a remainder. So this 36 right here is your remainder. So again, that's why I draw that line. So I know, okay, remainder is going to be in this spot. It's always going to be the last number that you have. Now, how do I figure out, those are my coefficients of my answer. How do I figure out what variables go after them? What variable do you think I'm going to start with? X squared. Why? How do I know I'm starting with x squared? Right, we take the highest exponent from the original dividend and subtract 1 from that exponent. And that gives us the exponent of our starting variable, which in this case, 3 minus 1 is 2. So we're starting off with x squared. What comes after x squared? Well, not without the coefficients, just in general. What comes after x squared? X. Then what? The constant, right? So essentially, guys, we're doing this. We're going x squared, x1, x0. All right, because remember, everything raised to the 0 power is 1. So you're literally going down the line in terms of exponent numbers. So this would be 1 x squared minus 5 x to the first plus 9 x to the 0 minus, how do I write my remainder? It's the same as long division. So we do 36 over what? X plus 3, so whatever we're dividing by. So to clean this up a little bit, I would have x squared minus 5x plus 9 minus 36 over x plus 3. So again, if you have a remainder that's not 0, just put it over whatever we originally divided by, which in this case is x plus 3. Not too bad, right? Any questions? All right, let's do one more example. So look on the back and look at number 3. Now, there's one thing that's very important when you're doing synthetic division, and that is every exponent has to be represented by a number. So every exponent going down the line, so 4, 3, 2, 1, 5, 4, 3, 2, 1, 0, they all have to have a number in front of them. You cannot skip numbers, all right, in the line. They have to go down by 1. So what's the glaring issue with this dividend? It's missing an x cubed. So right here, there has, well, not with a negative, but somewhere in that space, there needs to be something x cubed. If the x cubed doesn't exist, what is the variable, or what's the coefficient if it doesn't exist? 0. So I'm going to rewrite this as 3x to the fourth plus 0x cubed minus 5x squared plus 6x minus 5, all divided by x minus 3. Now, again, the reason you got to do that is if you don't include that 0 for the x cubed, it'll screw your division up. Like, just trust me on that one, it'll screw it up. Because what it will do is that it will skip over one of your variables that you need. So you'll end up ending with an x instead of a constant in your final answer. So I would make a note at the top to make sure all exponents are represented in order. From greatest to least. If not, replace the missing exponent with a coefficient equal to 0. Now, that also means that if it's not in standard form, you also need to write it in standard form first. So remember, standard form is when you're going from highest exponent to lowest. If it's not already in standard form, you need to rewrite it so that it's in standard form. So another thing with synthetic division that I would make a note of is that, and honestly, this goes for long division too, is that dividend must be in standard form. This is for either long division or synthetic. And to be perfectly honest, the 0 rule also applies to long division. So both of these notes apply to both types of division. And again, an example of exponents is that it should be going, for example, 4, 3, 2, 1, 0. All right. That's what I mean. Every single exponent must be represented. So since we were missing that x cubed, we had to include it here. Now we can set up our synthetic division. So you can draw your graph. So I do that, and then I draw my line. All right, that's typically how you set it up. You have a little box in the corner for your root. You draw a line, a horizontal line, and then your line to represent where your remainder is. What's going to go in my little box? 3. How'd you get that, Jasmine? Right, you take your root, set it equal to 0, or you take your factor that you're dividing by, set it equal to 0, solve for x, which in this case, x would be equal to 3. That's what goes here. What goes across the top? All of my coefficients in order. So all of these numbers in order are going to go across the top. And remember, your last number is what's going to be behind that vertical line. So this would be 3, 0, -5, 6, -5. Once you do that, you can start your process. So we drop down the 3. Then what do? Multiply it by your root, which is 3. So this would be 9. Add them together. Get 9. What's my next step? Multiply by 3. You get 27. Add it together. You get 22. Then what do? Multiply it by 3. Oops. You get 66. Add them together. You get 72. Then what do? Multiply it by 3. You get 216. Add it together, you get 211. So again, it's literally drop the first number, multiply, add, multiply, add, multiply, add until you finish. All right, it's the same pattern over and over again. Now, we got our coefficients and our remainder. So, someone besides Jasmine, tell me which coefficient I'm starting with for my answer. Or not coefficient. Which variable type, which exponent for my variable am I starting with? Not x to the fourth, x to the third. Why x to the third? So remember, you take your highest exponent, which is x to the fourth, and you're going to subtract 1 from it, which would give us x to the third. Now, guys, the reason that we're subtracting 1 from it is we're technically dividing exponents. So since we're dividing by an x, this is the same thing as doing x to the fourth over x, which if you divide x to the fourth by x, what do you get? X cubed. That's why we start with an x cubed. All right, because we're taking into account that since we're dividing x to the fourth by an x, somewhere in this division, we got to start with x cubed. All right. So my first number would be 3x cubed. What comes next going down the list? Nope. Again, look at these numbers down here. So plus 9x squared. What's next? Plus 22x. What's next? Plus 72 is just a constant. And then the 211 is my remainder. So how do I write that? What am I originally dividing? X minus 3. So this is my answer. Any questions on synthetic division? So again, synthetic is fairly easy, but again, you can only use it if your divisor does not have a coefficient in front of the x besides 1. If it just says x minus or x plus something, you can use synthetic division. If it doesn't, you have to use long. So long division will work for any polynomial division problem. Synthetic division will not. So be careful that you know the difference. Again, the one we did for warm up, you would not be able to do synthetic division before because of this 2 in front of that x. Any questions on that? All right, now take out your packet and turn to page. That's not it. Hold on, give me a second. Of course, I didn't copy it over correctly. Okay, turn to page 9 of your packet. So the other thing that we're going to talk about today is the remainder theorem. And the remainder theorem is very, very easy. All right, but it has to deal with division. All right, so what we're going to do first is that we're going to simplify each of these using polynomial long division. We're not going to use long division because check out what all of the divisors are. Look at what we're dividing all by. What could I definitely use instead of long division? Synthetic. So we're going to use synthetic because it's quicker. And I'm only going to do a couple of these. So we're going to evaluate using long division. So just to do it quickly, what am I going to put for my root up at the top for my box? 2. Then I have 1 minus 8, 18. And then I draw my box or my little chart. Drop the 1, multiply by 2, I get 2. Add it, I get negative 6. Multiply by 2, I get negative 12. Add it, I get, my brain's blanking, 6. Now, based off of that assumption, what is the exponent? What is the exponent of the variable that I start with for my answer? 1, because I start with an exponent of 2 originally. Subtract the 1, that's 1. So we just have an x. So this would be x minus 6 plus 6 over x minus 2. So that's our answer for part A. Now, on the flip side, we're going to take what we are our dividend and we're going to plug in for when x is equal to 2 and evaluate it. There's a reason to this madness, so just hang on for the ride. All right. So we're solving for when x is equal to 2. So I'm going to plug in 2 for every one of these x's and evaluate. So I get 2 squared minus 8 times 2 plus 18. So 2 squared is what? 4. All right, what's negative 8 times 2? Negative 16, and then the 18. 4 minus 16 is negative 12 plus 18. What's that equal to? Positive 6. Now, just from that, do you guys see a connection to the division and what we just did? First off, why did we evaluate at x equals 2 for the second part? Why do you think? I'll give you a hint. It connects to part A, or the red part. Why did we evaluate at x equals 2 for the second part? Okay, you might not see it yet. Let's do another one. All right, so let's set this up very quickly. What am I going to put for my root in my box over here? Yeah. It is. So that's a good connection. These two numbers are the exact same. All right, let's see if that holds up in court. So, next problem. What root is going right here? So if I set this x minus 7 equal to 0, what would x equal? 7. And I have 1, negative 2, negative 25. All right, drop the 1 down. What do I get for my next number? If I'm going. So what do I get for this number? 7. What do I get for the bottom underneath the line? 5. What do I get for this number? And then this would be 10. So since we're subtracting 1 from our highest exponent, we start with an exponent of 1, so x. So this is x plus 5 plus 10 over x minus 7. Now we're going to evaluate our same dividend when x is equal to 7. So I have 7 squared minus 2 times 7 minus 25. So this would be 49 minus 14 minus 25. So 35 minus 25, which is what? 10. So did Haley's assumption hold up true? Is 10 the same thing as our remainder? Yes. So, maybe it's a fluke. It can happen twice. Let's see if it happens 3 times. All right. So let's see if it holds up 3 times. So letter C. If I set the root equal to 0, what am I putting from my root in my synthetic division? -3. And then I put my coefficients across the top, 2, 11, 11, and then draw my table. All right, guys, walk me through it. First number. All right, someone besides Jasmine. Next number. -6. 2 times -3. Next number. Someone besides Haley and Jasmine. If you haven't talked today, you better start speaking. +5. Next number, if you haven't talked. -15. And the last number. -4. So, what is my final answer with my variables, Tomas? 2x plus 5. -4 over x plus 3. Good. We start with x because, again, 2 minus 1 is 1. So, then if I would solve for when x is equal to -3, -3 plus squared plus 11 times -3 plus 11, 2 times 9 minus 33 plus 11. So this would be 18 minus 33 plus 11. So 18 minus 22. So that would be -4. And once again, our remainders match up. Why do our remainders keep matching up? Look at what we're plugging in for x compared to what we're using to help us divide in the synthetic. What's the same? So guys, specifically look, how does that number connect to this number? They're the same. How does this number connect to that number? They're the same. How does this number connect to this number? They're the same. So essentially what we're doing is we're evaluating each of these equations at our root. So this represents our root that we are dividing by. This represents our root that we're dividing by. This represents our root that we're dividing by. All right. This is important because this is technically the process for the remainder theorem. All right. So essentially the remainder theorem is you're taking the root, plugging it back into the original function, and evaluating it. Now that's only part of the remainder theorem. So let's talk about this. So in formal words, when a polynomial p of x is divided by a binomial x minus a, the remainder will always be p of a. So in other words, if you took whatever value was here, or when you solve for x, and evaluate the original function at a, you should get whatever your remainder is. So whatever you would put here as your remainder, that would be what would happen when you evaluate your original function. All right. So in other words, if I ask you for the remainder, like what is the remainder when you solve this, you don't even have to solve it. All right. You don't have to go through all those long steps of division. If I just ask you what the remainder is, you can use the remainder theorem. It's way faster. So for example, given this division problem, I want to know what the value of r is. So the r is right here. And again, r typically stands for remainder. Mathematicians are not usually very fancy when it comes to our labeling. We're pretty blunt with that. So First thing you're going to do is you're going to take your root or take your factor and you're going to say, okay, I'm going to set x equal to what? So if I set that equal to 0 and solve, what would I get? 9. So what I'm going to do now is this is what I'm originally starting with. I'm going to find p of 9 for x squared minus 11x plus 22. So essentially, I'm plugging in 9 in for x squared, or 9 in for x. So I'm taking this 9 and I'm plugging it in for every spot that I see at x and evaluating it. And that should give me my remainder. So I have 9 squared minus 11 times 9 plus 22. And that you can either put in the calculator or you can do a quick evaluation. So that's 81 minus 99 plus 22. So that would be negative 18 plus 22, which is 4. So my hunch is if I went through and did all the division for that problem, I would get a remainder of 4. And we're not even going to check because based off of the problems that we did up top, that is true. All right. So if I ever ask you what the remainder of a number is, and I give you the original problem, you don't even have to do the division to figure out what that remainder is. All you got to do is figure out what the root is. So take your divisor, set it equal to 0, solve for x, and then plug that number in for every x in the dividend. Does that make sense? Pretty straightforward, right? Yes, no, maybe? All right. Now, on top of that, we can use the remainder theorem to figure out if a binomial is a true factor or true solution to a polynomial. All right. So I want you guys to think about this. By definition, a factor is x minus a is a factor of p of x divided by that is equal to q of x, where q of x is another polynomial. So if you divided your original polynomial by your supposed factor, all right, what do you think the remainder would be? So let's think about this. Recall back when you were doing, recall back to Math 2 and Math 1 when you were just doing straight up factoring. All right, I've been teaching this to my Math 1s today. All right, if I asked you to factor a polynomial, all right, typically you ended up with how many factors? 2, typically. All right, now, if I gave you one of the factors, that means that your answer should be another factor. All right, so you would have 2 bubbles typically. You may have more, but each their own. Now, let me ask you guys this. Did you ever, whenever you were factoring, see something weird like minus 4 over x minus 9? Whenever you were factoring, did you ever see something weird like that in your final answer? Are you sure? So, have you ever seen anything like, and I'm just going to pull this out of my butt, but have you ever seen anything like x plus 9 times x minus 1 plus 1 over x plus 3? Have you ever seen in Math 1 or Math 2 that? No. You would typically see x plus 9 times x plus 1 or x minus 1. All right. If you were to factor something, that'd typically be what your answer looked like. So let me ask you this. What do you think the remainder would be for a factor of a polynomial if you divide it? If that remainder fraction does not exist, what do you think the remainder is if it's a factor? Not 1. Because look at there, my example, it still has that 1. Look at the warm-up, guys. Our answer didn't have that fraction. What was our remainder? 0. So, with a factor, the remainder, if it's a factor, the remainder must be 0 for x minus a to be a factor of p of x. Now, that may not make any sense, but let's think about it this way. Say I had 256, all right? We're just going to think about this numerically for a second. You don't need to write this down. But say I started with 256, and I want to know if the number 4 was a factor of 256, all right? Meaning that if I divided 256 by 4, I should end up with what? A whole number, no remainder. Same concept. So if I divide it by 4, this would be 6, 24, 1, 16, and 4, 64. All right, because I get a remainder of 0. And again, I just did that very quickly. You don't have to write that down. So 4 is a factor of 256. Yes. Yes. Now, what if I said I want to know if 3 is a factor of 256? Then I should get a whole number when I divide 3 into 256, which in reality, this would be 8, 24, 1, 16, 5. So I would not get a whole number. I would get a number in a fraction or a number in a decimal. So is 3 a factor of 256? Yes or no? No, because I do not get a nice whole number. It's the same concept with polynomials. If that remainder is not 0, it's not a factor. All right. So sometimes when you think about harder concepts, sometimes just thinking about them like simply numerically can really help put it better into perspective. So with numbers, we know that two numbers are factors of another number is if we take one of those factors, divide it into the original number, and if it comes out to a nice number, then it's a factor. But if it doesn't, if we get like some weird decimal, then it's not a factor because we had a remainder. Same concept. All right. So that being said, that's the other part of the remainder theorem. All right. So again, you might want to write that down and star it or whatever you need to do because it's very, very important. Because I will ask you, is this polynomial a factor of this polynomial? And you won't have to do the division. All you have to do is the remainder theorem. All right. So let's do a couple of examples. So it's asking if x minus 3 is a factor of this trinomial. So what do I do first for my remainder theorem? So guys, how do I start the remainder theorem? How do I know what I'm plugging in for x? Right. Set x minus 3 equal to 0, solve for x equals positive 3. I then plug that in for all of the x's in my polynomial. So I have 3 squared minus 11 times 3 plus 24. And I'd evaluate that. And again, you could throw that fairly easily in your calculator, or you can do a quick calculation like me. So this would be 9 minus 33 plus 24, which 9 minus 33 is negative 24 plus 24 is 0. So that's my remainder. So is x minus 3 a factor of x squared minus 11x plus 24? Yes. So yes, it is a factor because that remainder is 0. Which we can also check Not by doing the division, but if we factor it. All right, if we factor that trinomial, because it's an easy enough trinomial to factor, all right, we can kind of check ourselves. You can't do that with all these problems, but in this case, since it's a quadratic, you guys should know how to factor a quadratic. So two numbers that multiply at 24 but add to negative 11, that's 8 and 3. So x minus 3, x minus 8. And sure enough, x minus 3 is one of the factors when we factor that trinomial. And again, you can't do that for all polynomials, but at least with quadratics, you can typically do that. You can factor it if it's not one of the factors. It ain't a factor. All right. One more. Let's try letter C. So what am I plugging in for x? -1. Set this equal to 0. Solve. You get x equals -1. Plug it in for every x you see. So I have -1 cubed minus 7 times -1 squared minus 11 times -1 minus 3. Now, I will tell you that if you plug this in your calculator, if you ever raise a negative to a power, you gotta put parentheses around that negative number. Otherwise, it'll just mess everything up. Just trust me on this one. What's -1 cubed? So if I multiply -1 by itself 3 times, what do I get? So what's -1 times -1? +1 times -1. -1. That's what -1 cubed is. So -1 minus 7 times -1 squared is +1 plus 11 minus 3. So this would be -1 minus 7 plus 11 minus 3. So -1 minus 7 is -8. Minus 3 is -11. So I get -11 plus 11, which is 0. So is it a factor? Yeah, our remainder is 0. Now, the last thing you got to do, and I'm showing you this example because you do have something like that on your test. So this is kind of important to take note of. What value of k will x minus 4 be a factor of x squared plus k to the x minus 52? So you guys may think this will be the hardest thing you'll ever do in your life. It's actually super easy because we're still doing the exact same thing that we do. Because we know that if we're given x minus 4, we're plugging in what for x? X equals 4. Now, they want to know the value of k, so that's what we're finding. K has to equal something so that x equals 4 is a factor. So if I plug in x equals 4 into my function, what do I want it to equal? If I want it to be a factor, what does it have to equal? 0. So guess what? If we want a factor, that means the remainder is equal to 0. So we're going to set this function equal to 0. At the same time, plugging in x equals 4. So this would be 4 squared plus 4 times k minus 52. And we want all of that to equal 0. And then from there, it's just simplifying and solving a linear equation. So this would be 16 plus 4k minus 52 is equal to 0. Combine like terms, I get 4k minus 48. No, is it 38 or 48? Whoever has a calculator, do 52 minus 16. That's, yeah, 36. That makes sense. So 4k minus 36 equals 0. How do I solve this equation for k? That's a 2-step equation right there. What's my first step? Add 36 to both sides. I get 4k is equal to 36. Divide by 4. K has to equal what? 9. So in other words, if I had x squared plus 9k minus 50, or plus 9x minus 52, then x minus 4 would be a factor. So your answer is k equals 9, but that's essentially what it's asking. What polynomial with a value of k would make x minus 4 a factor of it? So x squared plus 9x minus 52 is a polynomial where x minus 4 is a factor. All right, any questions on any of this? Okay, so for the rest of class, you now have enough information to finish your Delta math from yesterday. The rest of it was synthetic division. Packet work for this lesson is page 11 and 12. Is it? Yeah, page 11 and 12. All right. So you guys got plenty of things to work on. Get to work. Yeah. Yeah. Come see me at my desk. Also, you can do this in Starbucks mode if you'd like. Yeah. Also, if you weren't here yesterday, come see me. I got some stuff for you.
Thank you. We should be back before 4:30, but just in case we're not, we have to make our teacher sign it.
MPA.
Do you have other students also in MPA?
No, my mom's a choral teacher, so.
Yeah, we have MPA. What school does she teach at?
Pavlok.
Are they in MPA this year?
Yeah.
What are they singing?
I don't know. It's on my head.
We'll be there until like 10.
They're not going till Friday, though.
Ours is, yeah, ours is on Friday as well. That's why we have it now. It's so every teacher knows beforehand.
Oh, yeah. When Mariana gets back.
I've been in the choral program since like.
You probably met my mom. I'm pretty sure she came in to talk to y'all's class.
What does she look like?
Shorter than me, brunette.
I think singers saw her because we had the
singers.
whole,
I think so.
we had the whole thing on Monday and on the Friday, so we couldn't see her, and she was really there to help the singers out. So
Wait, come here.
we weren't really meant to see her anyway. What are you doing? She looks so awkward. It's okay.
What do we keep them?
Yeah, they're yours to keep. Jessica. Yeah, there's like 2 people online.
That's what she just said. She said no. She did. Now I have to go. Have to go.
Haley, can you hit the light switch by the thermostat, please? Thank you. I can't. I would. I don't have this thing called leave. I don't have this thing called leave, and I like getting paid. So.
You can't come to the course concert at 7.
Oh, 7 at night?
Yes, 7 at night.
Oh, I thought you were talking about MPA.
No, MPA is like it's only lasted till 30. It's not even that long time. Last year it was till like 6 at night. We were like,
Ah, crap.
what?
Wrong class. Sorry, guys. If you're trying to get into YouTube, it should be on block now. My dumb butt accidentally started it for my second period instead of y'all.